Hello everyone. So I have started the machine learning series and this is the second video. In this, we will be seeing the end-to-end machine learning project. And though this is going to be three videos, I will divide it into three videos and this is the part one. And what we are going to do is in this, I will walk through an example from end to end like how we start in the machine learning project, what are the various steps, like looking at the big picture, getting the data, explore and visualize the data to get insights, and how do we prepare the data for machine learning algorithms, how to select the model, how to train it, how to fine tune it using the hyperparameters, and how to present your solution. And also we'll have a quick look at the launch monitor and maintaining your system after we deploy it into the production. So we are going to work with the some real data and uh, so you can get data from multiple sources and I have taken data from one of the sites and this is a Californian housing data set which we are going to predict the house value based on the multiple parameters. Okay, so these are some of the libraries which we have which we are going to use. I will explain one by one when we use them. Right, let me just load all the libraries. And before we even start doing the loading the data and everything, I would like to highlight about the performance measure and what is that. So we use the performance measure to for let's say for regression problem is the root mean square and it give you idea how much error the system typically makes in its prediction, right? So in the root mean square tell us about how apart are you from the predicted value that are from the observed value. And this is the formula which means these are the predicted value, these are the observed value squared and divided by number of the observation and then the square root of that value, right? And let me run that. So this is one example. So these are list of actual and predicted. And what we can do, we can use mean squared error, which is again part of the scikit-learn library, right? And just to put that in RB, this is the 2.44. And how to interpret this? So if larger the value mean, larger difference and the worse the model fit the data means. If it is close to zero, then it means your values and the are uh, are good, your model fits the data pretty good. Also, you can create your own custom root mean square, and again, this is one custom function. We are taking the actual value, the predicted value here, the converting it to the arrays, and then using the same formula, the mine doing the just checking the sum, right? Sum of the observed values minus the predicted dividing by the number of observation and if I use this formula I get the same result what I got from the scikit-learn library function. Next we have a mean uh, sorry, this is the mean absolute error. It should be MAE. Okay, and this is the formula. So in this what we do, we take the mean, we take the observed value and the predicted value, we do the minus, take the absolute of that, sum it, and divide by number of the observation. So just to give an example, this is the true value, this is the predicted value, right? And the mean absolute error again, this is the scikit uh, from the scikit-learn library, right? It says 8.00. And how what is mean by that? If mean absolute error is 10, means the average mean square error is 10 units away from the actual value, and close them. So close the MSE value to 0 is better. This MAE, MAE. And you can do create the function, custom function for the MA like this. You have true value, predictive value. You are just converting into the arrays, NP arrays, and dividing it, taking the absolute and then taking the mean, and it will give the same result what was there earlier. Okay, so now we are done with, so these are the parameters which we use at the end to see what are predicted value, right? What are the true values and what are the predicted values. So next, let's start loading the data into the system, right? And this is the housing data, and this is what the data looks like. So we have this many of the variables in our data, right? And if you want to get more information, so the head means we are seeing the first 5 rows into first 5 rows of the data set, right? And if you want to get more information, you can just put info. So what it does, it tell you about how many entries are there. So these are the number of the rows, right? How many columns are there? So there are around 10 columns. So these are the column names, non-null content. So every value has non-null value. Okay, so the total bedroom has the some null values, right? And so this is float 69 and one object. So what is mean by that? There are 9 numerical values and one categorical value, the auction proximity. And let's see what the auction proximity is all about. So it has one, two, three, four, 5 different categories. If you want to get more statistic on the data set, you can use describe function. And what it does, it shows you the count means standard deviation, minimum value, 24 percentile, 60, 50, 75, and the maximum values in that particular data set for each the column. And what you can do, you can visualize all the data, right? And let me run this. This is going to create the histogram. I'm creating a histogram for on the complete data, right? And we can see, okay, in the longitude, latitude are different. The housing median age, so there are, these are the median age. We can see something around 25 has a lot, 35 has a lot, and more than 50, 60 has uh, big values. Total room is heavily right-tailed, similar total bedroom, population same, and the median house value is also same. Cool. So let's create our test data, and you might be wondering here. Uh, Before we move to the test data, I would like to highlight few things here. So in the histogram, as you can see, the medium income attribute does not look like it expressed in the USD, right? And after checking, what you mean it is a scaled and capped at 50, right? You see this one, the 15. So the number represents roughly 10,000. So actually 5 means the 50,000 values here and 150 means it's 150 values. So it is capped at 150K. And housing medium age. And this looks like also a capped value. Housing median value is also capped. So that's why you see the big value here. So what we can do in this scenario is, so again, this is a tricky question, whether you need to go back to the team which has collected the data in the real time, or you have to discuss with the subject matter expertise whether the data that we are collecting is correct or not. So let's create the test data, and you might be wondering what we have not even started anything, and we are creating a test data. It will string, but the idea here is to directly uh, divide the test data before we do anything, like before we see the data itself. And if we If we don't do that, then there is a problem, and that is called something data snooping bias. If we just see the data because we are very good with the identifying the pattern, if we start looking the data without even realizing, like without, if you start looking at the data patterns without dividing into the test and train and start doing some analysis, then it will create some bias, and that's called the data snooping bias. That's why it's a good practice to first just divide your data into test train and then start doing your analysis. So what we'll do, I will created a function here called shuffle and slip split, and so the NP random permutation is going to shuffle the data indexes. This is the test index, so it takes the data and the test ratio. So I'm doing 0.2, so 20% will goes into the test data, and you can see the 1615 is the training data set, 4128 is the test data set. You can also use the scikit-learn library. There is a called train test splits. You provide the how your data set, test size, random set for randomness, and it will create the same thing what was done by this function. And let's see housing data medium income. So this we cannot convert into the bins, and that's one problem, right? So to do that, what you can do, you can divide into the we can so I want to divide the whole income, median income into some bins so we can have some category around it. So PD cut is used for pandas cut function is used for that. You provide your data and you provide the bins and the labels. So this is what it looks like. It's converted all your median income into the categories. And let's see how the category looks like. So we have 1, 2, 3, 4, right? And we can see 2 and 3 category has the major count values, right? One has very less. Okay. So now let's do the move to the next part of stratified shuffle split. And what it does, it involves the division of the dataset into smaller group known as stratas, right? So what I will do, I will split those into 10 different sets. Test size is 0, 2, and random set is 2. And let me run it. So this is what the data set looks like. It's added the two more columns, right? The category one we have converted into the categories. Oh, sorry, we have added one column on the categories part. And you can also do the test train split, right? Test train splits using the same thing as stratified. Instead of writing this function, you can simply use stratify as the argument, and based on the income category you want to divide this in test train rate, right? Now we don't require the income category columns. We can remove that, and we'll move into the visualization part here. So what we have done, we have taken the glance of the data as a general understanding of what kind of a data we are manipulating, and what is the best way is so to visualize it, right? And it contains some geographical data, so it will be better to visualize. So let's do the plot, and we are doing scatter plot of longitude and longitude, right? This looks like California, right? And let's add the alpha pointer to show the density of where the more values are are available, right? So as you can see, these are majorly on the oceanic side. And you can add the color bar here, which represent which provide more information, right? And median house values where so higher the value is represented by the red column, and the lower values are represented in the blues. And you can see blues are mostly here, the reds are near the oceanic side. We can then start looking at the correlation between the data sets. So what I did here, I these all these data sets are numerical values, right? And let me run this. So to see what is the correlation with median house values with the other parameters, the median income is the more correlated, right, with the median house value. So higher the income, higher the house values is. And if you are higher income, then you are into the major category of income category, right? This is also very highly correlated with the median house value. So this is the scatter matrix, which again represent the all the median house values, the total rooms, median income, and the housing median age. And that's how you can create this scatter matrix using the attributes. So these are the attributes: median house values, median income, total rooms, housing median age. Next, let's plot the housing data. So this is a scatter plot. The x value is the median, right? And median income and the median housing. And we can see the positive correlation. If you try to fit a regression, you can clearly higher the income, higher the median house values we have. Okay, so moving ahead, let's create some new parameters, right? And so we want to create a room per house. So total rooms, what we have divided by the number of the household. So that will give room per house bit of average. Total number of the bedrooms and divided by the total rooms. So that will give the bedroom ratio. And the people per house, the population and the household, the people per house. These are the three new attributes which we have created. And we can again find the median house values. How, let's say the median income, which we have seen, medium category is correlated, and the population is negatively correlated here. Let's clean up some data. So we have, as I told in the beginning, the total bedrooms values has some missing values, and the best way you can do, either you can fill it with means, median, or if you have any other parameters, if you want to remove, you can remove. So what I'm going to do, I'm going to fill this value with the median values here. This is the Pythonic way, this you want to use the scikit-learn link, simple imputer. What you can do from sklearn import simple imputer. Simple imputer and strategy is median, right? Impute, and that's how you can do the same operation what is done here. Also, if you want to separate all the numerical columns, what you can do on the data set, you can select data type, include NP number. So all these data sets are on the housing numerical, right? And you can fit impute fit housing. So this is the training of this model, right? And what we are going to do, impute fit housing. So all the numericals columns are passed into this fit function on the training, and now you can see the statistics. If you want, you can see all the values, and now you can do the transformation of impute to dx. And the final values here is, after training we have the all the values are non null values, and we have a two uh, 12 columns. We have added three, right? New columns, this new columns, right? So this is this is the final data set after we do the cleanup. So this is on the numerical values. So if you have numerical based features, that's how you can handle it. But what if there are categorical, right? So the categorical is not going to work. Actually, all the machine learning models, they prefer data to be available in the numerical values, And it's always better to convert all your categorical into the numerical. So ocean proximity is the categorical, right? Its data type is object, and this is the head and tails of it, and you can convert your categorical text to the numbers. And there are two ways. The sklearn pre-processing, there is the ordinal encoder. So you put call the oracle, initiate your ordinal encoder, and fit the transmission of house category. House category is only one column here, right? And this is what this looks like. If you want to see what are the categories, so these again the same category which was there in that particular column, the auction proximity, right? Now there is a problem in this ordinal. So what it will do, it will assume the H1 ocean, inland, island, they are interlinked, like the category of very good, good, excellent in that scenario, because it assumes there is some order in the category, which is it's not the case in this particular scenario, right? So what is the best approach? So we can use one hot encoder. Again, it will deliver the sparse matrix of one value. So in the Python, we have one function called the get dummy values, right? So it is similar to that. So let's import the one encoder, create the instance of it, fit the transformation of housing category, and this is the values looks like. So it has created a sparse matrix. Sparse matrix is nothing, it's contain lot of zeros and very less ones, only where the values are there. So let me convert into the array. So this is the sparse matrix looks like. So it create a category. So we have five categories, right? One, two, three, four, five. And if the value is real, you just put one there. So pandas also have the similar uh, thing called dummies value, right? That's I told. So you can see the names. Ocean proximity is the feature name, and the out values are. So it create five different value. Ocean proximity one H ocean, ocean proximity inland, ocean proximity island, ocean proximity nearby. So that's how you handle your numerical and categorical. So what we have seen in this video is the performance measure which we'll use at the end, the root mean square and the mean absolute error. Also, we have loaded the data. We have seen there were some numerical value, how to handle those null values, how to handle those null values, how to visualize the data set, create how to create a test sets. You can create your own function. You can use scikit-learn, right? And how to see convert the data into the category. So you can PD cut. You can use to divide into multiple buckets. And the next thing which we visualize the all the plots and see where the more density is there, right? Also, we have checked the correlation between the various columns, right? And we have created few new attributes here. We cleaned up data, so there was some missing values we filled with the median. You can use the this approach, or you can use a simple imputer from skill scikit-learn library. We have separated the numerical and categorical, and it's the same thing. We can use simple imputers. So what we did, we first separated the numericals, fit on the impute. Impute is nothing but the simple imputer, right? We have seen the statistics all where all the values goes, and we have transfer impute or transfer. So this is all the values are there, and we are converted back into the data frame. So after doing that, there is no null values here. And again, the next part is how to handle the text and categorical data in this ocean proximity. So we have used the two ordinal encoder, which is one way to do it, but it is not correct way in this scenario. Second, we have used the one hot encoder, which create this sparse matrix, right, as with 0 and 1, and it created the five features out of 1H2 near ocean. Yeah, that's the end of the first part. We'll continue our conversation on the part two.